Are you looking to automate your server setups effortlessly? In this demo, we'll dive into how you can use Ansible Playbooks to deploy a Flask application with an Apache server and a Postgres database. Ansible will configure everything for us. Along the way, we'll learn about playbooks and how these simplify complex configurations. Our scenario centers around the fictional company TechCorp, where we'll automate the setup of the 2 web servers and 1 database server. We'll use Vagrant and VirtualBox to provision our virtual machines and then leverage Ansible playbooks to configure them seamlessly. Stay tuned until the end and I'll show you how to use env0's Ansible template. Let's get started and learn more about Ansible playbooks. Let's go ahead and run Vagrant up. Notice I'm running inside my Windows environment, so I've installed Vagrant and VirtualBox inside my environment. And running Vagrant up will create for us 4 VMs, a Linux control node we're going to run Ansible from, and 2 web servers and a database server. Once Vagrant is done creating those machines, we can access these machines with Vagrant SSH and then the name of these machines. And once we get into the control node, we can run our Ansible playbook. We'll start off with a basic playbook and then we'll see an advanced playbook. While this runs real quick here, the Vagrant file you can see here builds everything for us. This is not a Vagrant tutorial, so I'll leave this to you to go through it and take a closer look. Once this is done, we will resume the video and run our playbooks. Vagrant is done, and if I open VirtualBox, I see I have 4 machines. One is a control node, web server 1, web server 2, and a database server. Now what we can do is SSH into our control node, and you can do that with the command vagrant SSH control node. And Vagrant has already installed Ansible for us, and it's also cloned this repository for us. So if you run ls, and then you can change directory into Ansible, and ls again, you see here's our repository, and clear that, and look at what's in here. It's exactly what we have in our repository. So we can simply start by running Ansible playbook, inventory, and TechCorp playbook. This is our very first playbook, which is a basic playbook. And Ansible is going to go ahead and talk to our web servers. It's gathering some facts about web server 1 and web server 2. It's installing Apache right now. You can see Apache is installed on both web server 1 and web server 2. And whenever you see green, that means nothing has changed. If you see yellow with change, that means something actually has changed. Ensuring Apache is running, so this is just a check here. Deploy Apache config file, that's been applied. Running the handler, which is restarting Apache every time we make changes, depending on how we've configured this in the playbook, as we'll see in just a minute. And now this is the first play. You can see the first play is configuring web servers. It's made up of a few tasks. The next play is configuring database server, and that is also made up of a few tasks. We're gathering some facts about the database server. We're installing Postgres, ensuring Postgres is running, and configuring Postgres, and then running a handler to reload Postgres. And then we have a play recap at the very end, as you can see, showing us what has happened. So we have 3 changes applied to the database server and 3 changes to both the web server 1 and web server 2. So now that this is done, we can open a browser and go over to our web servers 1 or 2 to just see our Apache default page. And here we go. We are on the first web server. You can see the Apache 2 default page, and I can check the other IP address here as well. That will show me the second web server that is running, and everything looks great. Going back to our configuration here, let's go ahead and move on to the second piece and deploy our advanced playbook. And we can start from here. We don't have to restart from the very beginning. You can, but just to keep things moving faster, I can go ahead and run this playbook. And the difference is that this advanced playbook has a lot more tasks that are more advanced that will allow us to deploy the Flask application onto the web server, and it will configure the database with the proper permissions for the web server to access the database, and so on. So we see here we're installing a few packages. As we can see, we're running the Apache configuration files, updating that, creating that, enabling the Apache site, creating a document root, copying the Flask application, creating templates directory, copying an HTML template, configuring Apache to serve Flask, creating a WSGI file on both web servers. You can see this is happening in parallel, enabling the WSGI module, restarting Apache, check if the default Apache site exists, disabling the default Apache site, removing the default Apache site config, and then we have our handlers reloading Apache and restarting Apache. The next play is for the database, ensuring that Postgres is listening on all our interfaces and allowing Vagrant user to sudo as Postgres without a password in this case, and ensuring that Postgres group has the necessary permissions. Checking if the database exists, creating a new database, checking if the user exists, creating a new Postgres user, creating a simple or a sample table, add unique constraint to name column, inserting some sample data in there, verifying that the data was inserted. And here's what we've inserted. We have a table with these columns, ID and name. So I have a few items in here: computers, iPads, iPhones, Android phones. Granting privileges to my app user, which is really granting the application that lives on the web server access to the database. Running the handler to restart the Postgres database. And then we have a third play here, testing our web application, waiting for Apache to start, fetching a web page. And you can see here it's in HTML, the page that we're retrieving. It all checks out nicely. And in this case, we have a lot more changes that occurred on both the database server and the web server 1 and 2. And if we go to our website and refresh here, we should see now our Flask application is running. TechCorp items from the database, computers, iPads, iPhones, Android phones. These have all been retrieved from our database, and our application is working very well and it's served very well. Now, one thing that's important about Ansible is that it's idempotent. So I can run it again and nothing will change unless it's specified to change. So there's no harm in rerunning multiple times. You can see a lot of this has already been done, and Ansible will go out and check if there's something new that has to be done. Otherwise, it will just go through until the very end. There are some changes that we see here, like restarting Apache, enabling the Apache site, and all that, of course, you can view inside our playbook. And here's the advanced playbook. I'll leave that up to you to go in and read through this. It's not too difficult to understand, but I will go and take a look at the simple one and go through this one line at a time, and starting with the configuring the web servers first play. Under here, we're specifying the hosts are going to be web servers. And there's an important concept, which the inventory file, and the inventory file here is where we're telling Ansible what servers are there and what IP addresses are available for each of the servers. So before you run the playbook, you have to have the inventory file ready to go. And you can see we have a group called web servers. And here we got web server 1 and 2 and the IP addresses of each. And we have the DB servers, which is just the DB server and its IP. Now, back to our playbook. So we have a variable. You can define some variables and reuse them later. So the variable domain techcorp.com. Also become yes, that means we're going to become a root for the entirety of the play unless specified otherwise. We have tasks, and the play is made up of a number of tasks, as you can see here. And by the way, this is all in YAML. We have our first task, installing Apache. Apt is basically using apt, the package manager of Ubuntu, since this is running on Ubuntu. And we're installing Apache 2. And there's a notify key here, which means that whenever this task is done, we want to notify a handler. In this case, this handler is called restart Apache. And this handler here does something. So in this case, you can see the service Apache 2 gets restarted. And then after installing Apache, we're ensuring that Apache is running. So we have the state is started, enabled is true. And by the way, these are all modules. So apt is a module, service is a module, template is a module. These are all Ansible modules. And a lot of these are built in. You can import modules from Ansible Galaxy that others have written, or if you have written those modules yourself. But that's a conversation for another video. Here's the template. We're sourcing from the templates Apache conf.j2 right here. The destination is the Etsy Apache 2 sites available, and the variable domain.conf. The variable domain is, in this case, techcorp.com. So that will get replaced here. We saw the handlers. And then the second play is configuring your database server. So you can see we are also becoming root, and the host is the DB server as a group. We have another variable, Postgres version is 14. We have a few tasks installing Postgres. We've seen the apt module already. And we also have the apt update cache, allows us to run apt update to update the cache before we install Postgres. Then we have the task to ensure that Postgres is running. So we're running service and we're checking that Postgres is running. And then configuring Postgres again with a template file, as we saw before in the web servers play. We have a source, we have a destination, and we have this variable being replaced with 14 over here, which is the Postgres version that we're running. And then we're notifying the reload Postgres handler. So once this task is run, the handler will kick off and it will reload Postgres for us. And that is pretty much it from a play perspective. Again, you can go and check the advanced play, similar to what we did, but there's obviously a lot more tasks. We have about 261 lines here, so feel free to go through that and take a look at yourself. As promised, let's jump into env0 and take a look at the templates that we can create for Ansible. I already have one template here, so let's look at that. And I built this template as part of a previous video that you can also find on the env0 blog. And here what we were doing is we're creating a template specifically for building something in Docker. But you can see we've selected Ansible as our provider here, or our template type. And here we can specify what version of Ansible we want to run or leave it at latest. We can also see the SSH key that we're going to use, because remember, Ansible needs to SSH into the machines, the VMs that it needs to configure. So if you're SSHing with a private public key pair, you need to specify the key here. Then you can tie this to your version control system, and this will tie into your repo. And if your Ansible playbook lives in a folder inside of this repo, you can specify that here. Otherwise, if you don't specify anything, it will look at the root of the repo for the Ansible playbook. Then you can specify the variables with this variable Ansible CLI inventory. So the name is inventory for our inventory file where we have all the machines and their IP addresses. And after that, of course, you can add this template to one or more projects. In this case, we have it under the Ansible tutorial project, which we'll take a look at right now. And since we've deployed this in the past, we can see the deployment logs to give you an idea of what's going on. So a lot of these deployment logs are similar in env0 if you're running Terraform, if you're running CloudFormation or Helm. So what's different is down here, Ansible Galaxy. In this case, we're not using any modules for Ansible Galaxy. We are using a check to check the playbook. So before we actually commit, similar to Terraform plan, we are checking the playbook to make sure everything is fine before we actually commit. Down here, we're actually committing. We're running Ansible playbook with the inventory file and the playbook itself. And that will go out and run through the playbook, create everything that needs to be created, and we'll configure what we asked it to configure. And of course, we have our variables that we saw before, the CLI inventory file, and we have one deployment here that's successful. And you can have the settings, of course, to approve your plan automatically, or you could also schedule the deployment, destroy, You can check for drift detection and so on. And that is it for the demo. I hope this has been helpful for you to understand how you can use Ansible playbooks to run configurations automatically without having to do this work manually. The work that you put in to build the automation will definitely pay off dividends when you are trying to reproduce your environment. One last thing, of course, if you want to destroy your environment after you're done, all you need to do, exit from here and run vagrant destroy and force it. And that will go out and destroy the 4 machines that we created. So it's forcing the shutdown of each machine one at a time. And once that's complete, we'll see that in VirtualBox, all of my machines have been destroyed. That is it for this demo. I hope you enjoyed it, and I'll see you in another video.